Hello there, welcome to my channel. In this video, I'm going to present to you about the electronic configuration of an atom. Electronic configuration such as 2, 2.8, 2.8.18.2, 2.8.7. Okay, all these is we call it as a electronic configuration, or we also will call it as a electronic arrangement. Okay, electronic configuration, they have a close connection with the period and group of a periodic table. Let us look at this periodic table. This is the periodic table of the elements. Okay, what we are going to look here is the period of the periodic table. Okay, this is, we call it as a period. All right, so here's the first period, second, third, fourth, fifth, sixth, and seventh. Okay, this is the period. Okay, and then now we will look at this group. Okay, this is the first group, second group, and here will be group 13, 14, 15, 16, 17, 18. So in periodic table, total we have 18 groups. Why here is 13? Why not 3? Because this group, let me color it in a green color. Okay, so these groups of elements here is we call it as a transition elements. So these transition elements, we have 10 elements in a row. So it comes like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Alright. Okay. For IGCSE syllabus, the first 20 elements is the one taken into account. Alright. Okay. So now we are going to look at how this electronic arrangement or configuration of each of these elements can be arranged. For example, we will take sodium. All right, sodium. So here will be sodium and A, 11 and 23. So we will take the number 11. Okay, this is the electronic number. Okay, this is supposed to be a proton number. Since proton is equals with the electron number, so we will take this number. All right, 11. So this is the example one that we are going to do, and we take example of a fluorine. All right, so fluorine here, this is 9 electrons, and here they have 19. Okay, so we are going to do two example for now. Na, they have 11 electrons, and fluorine, it has 9 electrons. All right. Okay, now we have sodium with 11 electrons. So now the question is, how are we going to arrange this? Okay, first we have to follow the maximum number of electrons that can fit into the number of the shell. Okay, now we look at the number of the shell, the first number. Okay, the first shell here, the maximum it can go up to 2 electrons. Second shell can go maximum up to 8 electrons. The third one, the maximum electrons that it can fit in is 8 or 18. The fourth one is 8 or 18 or 32 electrons. Okay, I will explain here with the different elements. Okay, so this is your shell. All right, this is a shell, and sometimes they also be called as orbits. Okay, so first, second, and third. Okay, now let us look at number 11. Sodium. Okay, so first shell we have only a maximum can fit in around 2. So we write there 2. Alright, so we just have to minus 11, we minus with 2, we will be getting around 9. Okay, we have balanced 9 electron and we can fit in another 8 into this second shell. Okay, now what happened? 9 minus 8, we have 1. Okay, so this is your electronic configuration or arrangement of a sodium. So what does this mean? 2.8.1. Okay, now you can see this 2, 8 and 1, right? Okay, this is number of the period. Okay, so this is number of the period. So the period for sodium is period number 3. Alright, now the last number here, the last number which is 1, okay, call it as a valence electron. Valence electron is the number at the outmost electron. Okay, so this valence electron also represents the group. Alright, so it represents the group. So now sodium, we have it in period 3 and group 1. Now we look at sodium in periodic table. So just now we have given that sodium is in a period of 3. Okay, so 1, 2, 3. Okay, this is the period 3 and group 1. Okay, and group 1. So we look at here. Now we found sodium, which is here. Alright. Okay, next we will move to fluorine. Okay, now fluorine has 9 electrons. So the first shell can fit in maximum 2 electrons. 9 we minus with 2, we have 7 left. Alright, so 7 is in your second number of shell. Now 2 and 7, okay, this is period 2. Alright, this is a second period. Period number 2. And the valence electron here is 7. So which shows group 17. Let us check. Alright. Okay, here let us check out fluorine. Period 2, 1 and 2. This is second period. And we have a group 17. So this is your fluorine. Okay, now let us look at a harder example. Let us select, let's say we take rubidium for now. Okay, rubidium has a electron of a 37. Alright, so let us make a calculation based on this rubidium. Okay, now we have a rubidium here 37 electrons. So if let's say you are wondering how about this electronic arrangement for this rubidium. So the first shell we can fit in is 2. Second obviously is 8. Alright, and here you are unsure. Okay, if you are unsure, let us go back to periodic table now. Alright, now we look at the period for this rubidium. Alright, rubidium is located here, and they have 1, 2, 3, 4, and 5 period. So the period here is 5 and group is 1. So if period is 5, period number is 5. So it means that this rubidium, they have 5 shells. Alright, so we just make a space for this. Alright, so the number that we certainly knows is 2, 8, and the last one, which is the group. Okay, here's group 1. So we have to put here group 1. Alright, now we just minus 37. We plus these numbers. 2 plus 8 plus 1, we got the 11. So we minus, we still have 26 numbers. So how do we fill up inside here in this box and inside in this box? Okay, so we have this third period option, which is a 8 and 8 or 18. So if let's say we put here 8 and we put here 8, it is just 16. Alright, so there is 10 left. So we cannot put the 8 there. So what we can do now, so we select the 18 as the highest number for now. So we put here 18 and the next one we put here 8. So 18 plus with 8, yes, you do have this 26. So your electron arrangement for rubidium is 2.8.18.1. This is the electronic configuration for rubidium. Now let us check for iodine. Alright, let us check for iodine, which is iodine has 53 electrons. Okay, let us check the iodine's period and also the group. The group obviously we know is 17 and the period is, we have to start from here. Alright, start from here. The first period, second, third, fourth, and fifth. Alright, so now we know that if it is a period 5, fifth period, and we know it has 5 shells, so the first shell has 2, second has 8, and we know the last shell, which shows the valence electron, it has 7. 7 shows group 17. Alright, group 17. Alright, so the balance we have to find for the third shell and the fourth shell. Let us minus 53. We minus with, we plus 2 plus 8 plus 7. So we got that 17. 53 minus with 17, and we will be getting the about 36. Okay, about 36 electrons. So we need to get group 3 and a period 3 and a period 4 combination of a 36 electrons. Okay, so how is it? Okay, now let us check this. Okay, now when we are following, oops, So here, when we are following shell 3 and shell 4, for shell 3 the maximum is 18, and the shell 4 we have 8, 18 or 32. Okay, let's us apply this in that column. Okay, to get 36, so what we have to do is number 3, period number 3, we make it, we have to use number 18. Okay, so we just place 18 over here. So 36 minus with 18, we still have another 18. So which is one of the maximum options at the shell number 4. So we can put here 18. Alright. So the electronic configuration for iodine is this: 2, 8, 18, 18, 7. So which has a period of 5 and a group of 17. Alright. Okay, in this video, you have learned about electronic configuration, where we learn to arrange the electron based on period and also the group of the periodic table. Okay, I hope you learned something from this video. I hope you enjoy it. Okay, if you do, please subscribe and like this video. Alright, I'll see you in a next video. Thank you very much.